Hello, this is Dr. Mears. Today we are going to be learning about application problems writing an equation given a table. So let's see what's going on in this problem. Tony's garage on Main Street charges a fixed amount plus an hourly rate to service a car. The table below represents different charges for different amounts of service. Hours of service, total charge. So this is going to be our X and this is going to be our Y. The reason why I know hours of service is because this is the input. You input hours and then you get out a total charge. So it doesn't go the other way. Or actually, they might tell you what the total charge is. But for this problem, the X is the hours of service, which is our input, and the Y is the total charge, which is our output. What does the X variable represent? There we go, the hours of service, or number of hours. What does the Y variable represent? Total charge. A little dollar sign. Okay, what's next? For 2 hours of service, the X value, the total charge of Tony's garage is $153, the Y value. So that's actually in our table here, 253. So as you can see, 2 is the X and 153 is the Y. This sentence represents the first point. So when you're doing application problems or even that summative that you have with the data plans, you're going to have a sentence that's going to give you the point inside the sentence. So you are going to have to pull out the information where your 2 is the X value and your 153 is the Y value. So please make sure you're looking for that type of sentence when you're reading a problem. Okay, next. Choose another point that can represent the second point, x2, y2. Fill in the blank and the coordinates below. So first, let's see. Write the numbers as a coordinate. So let's pick another point here. Let's do 10, 585. Why not? So I'm going to choose 10, 585. Okay. So for blank hours of service, X value. So I chose 10. So for 10 hours of service, which is my X value, the total charge at Tony's garage is, I'm looking for the Y value, and that would be 585, and I'm going to do some dollars. So for 10 hours of service, the X value, the total charge at Tony's garage is $585, which is that Y value. So the coordinate 10, 585. So please know that this is called a coordinate. So when I ask you for a coordinate, you're going to be doing the parentheses with the comma, and you're going to put the X value and then the Y value. So since this is our X2, Y2, and since we have X1, Y1, in order to make an equation, we're going to need to use the slope formula, which is this. So our slope formula, this is what I'm going to actually write down my points again, 153, 10, 585. And the reason why I like to write them one on top of each other is because it's going to make it really easy to substitute in y2, y1, x2, and x1. So this was x1, y1, and this is x2, y2. So in order to do our slope formula, we have to do y2 minus y1 in the numerator. So I'm going to put my subtraction symbol there. So all we have to do if you write them on top of each other like this, you just go to this one right here, the y2, because that's where we have to start, y2, which is 585, and you just subtract the number above it. That's it, because that is y1. So it's just 585 minus 153. So really, if you want to set it up like that, one point on top of the other, you subtract the y's, and then you subtract the x's. So this is x2, which is what we need, 10, and I always like to put my minus sign, and then this is x1 is 2. So nice and easy filling it in, 585 minus 153, there's your numerator, and 10 minus 2, there's your denominator. Now we're ready to go through and do some of the calculations. So on your calculator, please subtract 585 minus 153. And that's going to give you 432. And let's subtract 10 minus 2, which is 8. And let's see if we divide 432 by 8, it does come out to 54. And so our slope, so I just divided that out, and that does come out to 54. So our slope is 54. Now, if we were to represent this, because I'm sure we're going to make some type of sentence next, we can represent our slope as 54 over 1, And so remember, this is the change in y, which is the change in the total cost. And remember, this is the change in x, and that is the change in the hours. So it can convert to a fraction. Sometimes your slope may come out as a fraction. That's absolutely fine. Because remember, it is the change in y over the change in x. So I'm kind of just getting ready to see what comes next. So let's see what comes next. Let's flip our paper over. Okay. Part F. Now substitute the slope. Now remember, slope is m. I always like to write my variables on top of the words that they mean. It helps me to organize my work, so please do that. So write the slope m and 1 point, so they don't, either point you want, into our y equals mx plus b, our slope-intercept, to find the y-intercept, and the y-intercept is b. So doing a little annotating, slope was m, the point was xy. Here's my slope-intercept form, and I'm looking for my y-intercept. So my slope was 54. The point that I'm going to pick, and if you flip it over, I'm just going to pick this first one here, 2, 153. Remember, you could use 10, 585. Either one works. So I'm just going to pick 2 and then 153. And so this is my x and this is my y. So we're going to manipulate the formula, y equals mx plus b, in order to find this missing value of b here. So our y was 153, so here's 153. Bring down your equal signs. See how I put the y and then underneath I put the value? Here's the equal sign. Underneath the m, I'm going to put the value of m, 54. Underneath the x, it is multiplication here. It's always multiplication. So underneath the x, I'm going to put the x value, which is 2, and then plus b. So next step, always multiply these two. So 153 equals, taking out my calculator, 54 times 2 is going to be 108. 108 plus b. Now, because this 108 is positive, in order to get b by itself, we subtract it from both sides in order to undo it from this side, so that when I bring my b down here and my equal sign, I can find what my b value is. So I'm going to subtract 153 minus 108, and I get 45. So my b, my y-intercept, is 45. Okay. Let's see what it says. Now add this coordinate to the table, please. So what this coordinate represents, remember when I said coordinates, there's going to be an x and a y. So this is the y value, so this is 45. Now what a y-intercept is when the value of x is 0, because the y-intercept is where that line crosses the y-axis. And all the time, our x value will be 0, and then we will have a y value that goes along with it. So here is the coordinate that we have to add to the table. So I was wondering why these blank ones were here. Here's 0, 45. So just taking it back to your summative again when you're doing your data plans, please make sure you show the y-intercept in your table. So it's always good to show that 0 and then what your y-intercept value is. I am going to be looking for that when I grade your summative assessments. Okay, going back to the other side, part G, now that you have slope, M, and y-intercept, B, please write the equation in slope-intercept form, so y equals mx plus b form. If you're having trouble with this, please make sure you're writing your variables on top of the words or on underneath of the words that they mean. So now that I have my m and now that I have my b, I can take this variable out and substitute 54 in. So now I'm at y equals 54. Put my x value there, plus, and I know my b is 45, and it was a positive 45, so that becomes positive 45. So my slope-intercept form of the equation is y equals 54x plus 45. Next, part H. I should have set up the labels and everything. Sorry, this video is going to be a little bit longer. Please graph your equation. Don't forget to make an appropriate scale entitled each axis. So this is going to be number of hours down here. and over here will be total cost. And on the side, I'm going to write my equation, y equals 54x plus 45. And in my equation, this is my b and this is my m. Now remember, our b is our y-intercept. It is the coordinate 0, 45. It is where it intersects this y-axis. This is the y-axis right here. So it sits on this line right here. This is the x-axis, remember. So I need to make sure that I'm going to be able to plot 45. Now my slope, my m, equals 54 over 1. Now remember, this was the change in y. And if it's positive, I'm going to go up 54. Wow, I need a good scale. And I'm going to go, this is the change in x. If it's positive, I'm going to go right 1. Well, that makes it kind of easy because here's the change in x. So for scale for my x-axis, I'm going to count by 1 because we know we have to go right 1, so that's really nice. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's just go to 10. Okay. Now on my y's is a little bit different. I know I'm going to have to plot 45. I'm going to have to go up 54. So what I might do here is I might count by 50s. The graph isn't going to be perfect. If we wanted a perfect graph, we're going to actually learn how to do a perfect graph using Desmos coming up, but that's not for today, and that would give us a nice perfect graph. But because we're sketching it right now, let's go by 50s. So this would be 0, 50, 100, 150, 200, 250, 300, 350. Let's go to 400. That looks pretty good. Okay, so each one of these, we went by 50s, and each one of these, we went by 1s. Okay, now we have our scale set, and we are ready to graph. So remember, this is the total cost. This was the y-intercept. So first, let's graph that point. Now, and please notice, this is 50 here, and we have to plot 0, 45. So I'm just going to kind of get close to that 50 point. Remember, this is not going to be perfect. So here's my home base. Here's my start point. From my start point right here, I have to do my slope. These are the directions. So numerator is 54, change in y. I'm going to go up 54. So that's a little below 100 because remember I counted by 50, so a little below 100. From there, I'm going to do my denominator, which is my change in x, which is right 1. So I'm going to go up 54, right 1. I'm going to do it again. Up 54, right 1. Up 54, right 1. Up 54, right 1. Up 54, right 1. Okay. Again, it's not going to be perfect. I tried my best. If we wanted perfection, we would draw a nice line. We would use a computer. So it passes through, and I go up 54 and right 1 every time. Okay, getting to my last two questions. What is the relationship between the variables of the situation? So I'm asking about the variables between number of hours and my total cost. So let's look. As the independent variable, so now my independent variable, remember, let's put our variables over the words that they represent. So my independent variable is my x. So this is my number of hours. So actually, I don't even write it there. It was writing it there. As the number of hours, independent variable increases. And so I'm actually going to add that here. I'm going to put independent. So I like to label, as you can see, everything. So that's my independent variable. So I'm assuming that this is going to be my dependent variable, since this is my independent. So let's keep going. As the number of hours increases, because I'm increasing my number of hours, as I read the graph, remember, from left to right. So as my number of hours increases, let's look. Oh, the line is going up. So I'm assuming that my total cost will also increases because as I read this graph, my line is going up. So the total cost, dependent variable, check, that's my y. And I'm going along, the line is going up, so it's going to increase. If the line was going down, you got it, it would decrease. So we're looking for either up or down. Now, I don't want you to use the words up or down. I want you to use the words increase or decrease because this is how we represent the language in mathematics. And the last one, how much would Tony's garage cost if you needed 23 hours worth of service on your vehicle? Show, work, or justify your reasoning. So 23 hours. So pulling out, remember, hours is my x value. What I'm going to do is I'm first going to do this using the equation y equals 54x plus 45. Since they gave me the x value, I'm just going to substitute the 23 in for my x. And inside the calculator, you can clearly just put this down and it will give you the answer. So inside your calculator, and I'm talking really 54 parentheses 23 plus 45, that's going to give you an answer of 1,287. 1,287. So it'll cost a total 1,287 total cost for 23 hours. Okay, you know, let's put of service. I always like to put a complete sentence. You never know, I probably could be looking for points. Now, this is the equation way of doing it. I just wrote equation over here. That's the equation way of doing it. You can also use the graph, and using the graph, in order to justify your reasoning, you would have to tell me. So if you use your graph, you would have to extend this all the way over to 23, and you would have to look all the way up to see where your line went. Now, we can't use the graphing method here because I don't go to 23, so I'm not going to get a very good estimate using the graph. When we do graph using Desmos and we get a nice graph, we're going to be able to go to that point. So I will explore more with using your graph. But for now, I would like you to know the equation method where you're substituting in the value of the variable, remember ours is x, into our nice equation that we made that's in slope-intercept form. And then doing the math, 54 times 23 plus 45, getting our answer, and then writing it in a complete sentence. Sorry, I banged the table there. Okay, this has been a lot. So congratulations, you have finished your writing an equation of a line in slope-intercept form, giving various pieces of data, and this one has been giving a table. So hopefully this helped, and get to work. Thanks.